project is self-balancing robot. It's kind of like a little Segway. So on the bottom, there's a little red chip that gives me the angle that it's at using a gyroscope and accelerometer both. And then I have an Arduino Due, which is basically a more powerful version of an Arduino because it needs to process the angles really fast. And then here on the wheels, I've added another loop, which makes it stay in the same spot. Because I was having trouble when it would start like running away, because it would be slightly tilted, but it would think it's at 90 degrees, so it would like run away and then eventually fall over. So using the wheels and there's a little black thing that spins and can tell me the position that it's at. So. Well, yeah, it's supposed to bounce, but the controller isn't turning on. Well,
Any new batteries?
Yeah.
Something always goes wrong.
All right, here we go.
Feel this up so that you can actually get traction.
So yeah, like I said, it uses the gyroscope on the bottom. Anyway, it was too small. Yeah, it uses the gyroscope on the bottom and the motor encoders, which give me the position, and uses those to make it stay in the same spot and balance. And in the future, I would like to be able to control it with the PS2 controller and the joysticks here, but unfortunately that's a lot harder than it sounds. So that's my future path, I guess, in the last few days at least. I learned it's like a ton working on this project. It's coming into Bootstrap. I didn't know very much about coding at all, and I guess I took a pretty ambitious project, but I learned a lot. And I feel like it was a success right now, even though I can't control it. I think it was a success. So, any questions?
What was the hardest part of your project?
The hardest part of my project was getting to balance. I spent about 2.5 weeks on that, just because when you have the angle and you can see that it's starting to tilt, getting the right motor response to write it perfectly is really hard. Because if it's too high, if it's too much, then I'll just overshoot by a lot and tip over. If it's too little, it'll just fall over. So finding the right thing to do that. And initially, I used a PID, which is proportion, integral, and derivative computation. So it's a little calculus, but in the end that didn't work because the system's too unstable. It's constantly tilting back and forth, and the PID can't respond fast enough. So I ended up using a sine function.
What about?
I'm guessing you were inspired by the Segway. Is that right? Is that how?
Actually, I mean, it was in the project booklet. I guess this was inspired by the Segway, or maybe vice versa.
Did you get a chance to? Did you get a chance to study at all the history of how the Segway was invented, or anything about the guy?
I didn't, but I might have to do that.
It's a great story. It's a lot of failure that are on the way.
I can tell.
So that's just a regular PlayStation.
Yeah, actually,
thing?
it's an off-brand. So
Okay. So how do you get it to talk to? I mean,
Well, there's a receiver. So this black thing is the thing you actually plug in with PS2.
okay.
But in the dock, there's little metal pins, and you can hack it and plug it into the specific pins of the Arduino,
Okay.
and then you can do the reading off that using water.
But like going forward and backward, I mean, is it the same things or?
Well, it gives you. I actually pulled some code off the internet to read this because it's really complicated to decipher every single signal it sends. But the reading it gives me is a value between 0 and like 250 or so. So 250 being up all the way and 0 being down all the way, and the middle being like 125. So I use that to calculate, to tell me where I want to go and how fast I want to go. Yes.
What's the minimum control loop time that you need to make it work?
Well, like I said, I'm using a Due, which has specifically for its faster processor, and it has more pins, which is also a plus. But I've never really had any trouble with the accelerometer. What I have had trouble with is the sensors, because the wheels are huge, but the sensors are small, so the sensors spin real fast. So the problem is if I tried to sense a change one time every time I ran through the loop, it wouldn't be fast enough. So I put an interrupt, which basically says if it senses something, it's just going to stop. The Arduino is going to stop wherever it is, and then pay attention to the sensor for like a split second. So that's how I fix that. But yeah, I did have a problem only with the speed sensors.
So how often do you sample the sensor?
Well, one rotation of the wheel is the sensor sends a signal 480 times. So that's a lot. And the Arduino can't run fast enough, especially if the motor's running at full speed.
Yeah.
It starts to break down.